Hi guys, it's Mrs. Shannon, and so I am going to try to do a little screen recording to help us with our graphing and our calculations here for that mouse predator prey lab that we did. Now, I do not have the data in front of me, plus I don't want to do the exact data because I want you guys to still try to figure things out and whatnot, and if I just put the answer there, then, you know, it defeats the purpose. So I'm going to kind of fake a little bit of it here just to kind of give us something to use to show how to do this. So the first one, whoopsie, here we go. Let's go with this dude right here. Okay, so I think the average for this first one, and maybe because I'm putting my hand on it, 3.2. And I'm just going to give these as my averages just so I have something to put down. Let's just do 4 to make it easier. Okay, so let's just say these are my averages or my means, and you guys can probably calculate it from there. And then you're going to use your formulas to calculate your standard deviation and standard error. I'm going to, for this first one, go with a value of 0.11, which I think actually might be your standard error for this particular one. Hint, hint. Not 100% sure, so double check with the calculation. But I'm pretty sure it's something close to that. When it says plus or minus 2 SE, that means what would 2 times this SE be? So we just have to take that 0.11 times 2, and we have 0.22. So we're going to start, I'm going to use this data right here, so I might go up and down from it as our data that we're going to use to graph. Now, of course, you'll have your standard error and 2 times the standard error filled in after you do the calculations as well right here. Okay, so let's see, nope, come on. Let me go ahead and scroll down. I know, there we go. I had this right here. Okay, so let's see here if I can zoom in a little bit more, maybe not. Come on, zoom in, zoom in, zoom in. It's not letting me zoom in. We're just gonna have to go with it. And so what we're gonna do here is, first of all, this first question is just asking you so I can see if you know how to kind of solve for standard errors, to write out a formula, and you just have to do it for one. And so let's just say that we do now it goes through. SE, and I don't know why it's doing black when I hit blue. SE equals, well, I'll just stick with black. Standard deviation over the number of samples, square root of the number of samples. And so again, I'm going to go with the sample data that 1 SE, 1 standard error is 0.11, which means that 2 standard errors would be 0.22. And that's just asking for a sample calculation. How did you set it up? When you get down to the graph, okay, you always want to check what you need to graph. In this case, you're comparing average mouse survival times on different ground colors. Okay, and then we're going to draw on error bars. Now, really quickly, and I'll go through this in class, when you're setting up a graph, it's a good idea to use the TAILS checklist. It's very similar, it's just maybe out of order to the checklist that you have in your notebook. If you just want to use that checklist in your notebook, that's fine. On the actual AP exam, you will have to construct at least 1, if not 2 graphs. But for one of them, you will get points just for setting it up correctly, just for having your title, just for setting up the intervals and putting the labels in. So please, please, please get used to setting it up correctly because those are easy points. So T stands for title, A stands for axis, I stands for interval, L stands for label, and S stands for scale. So when I approach this, I usually start with axis and label. I do them together. So I know that this is my x-axis and my independent variable goes on it. So the one I have most control over up here between mouse survival and different ground colors is the ground color because I can choose on the computer simulation. And so I am going to just go down a little bit here. Oopsie, ooh, fun times. Go down. Let's see if that kind of works. No, not really. So I'm actually going to put the label over here just so you can see my tools down there are kind of in the way. Okay, so the ground color is going to go on the X. And then that means the average mouse survival time will go on the Y. And of course, we have to put our units. If we don't have units and it is a measurement, then it won't count, okay? Next thing I usually do is I usually do my title last, I'll be honest. So I'm gonna do interval and scale. Scale means we wanna make sure to use the entire graph or as much of it as possible to spread our data out so it's easier to analyze. Interval is like what we count each line by to make sure that we're using up the entire scale and so that our relationship between our data points, the trends that we see are true trends. And so to do it, I usually do them together. To figure out how to maximize your scale and keep your intervals consistent, the foolproof way is to count the number of lines divided by the max value for that data set. So if I count these lines, 6, 7, 8, 9, 10, 12, 13, okay, I think there are 20 lines. You can probably double count them. Oopsie. Let me get rid of this so it's not right there. Okay, no. Here, I'll just write it in green. Lines divided by the max value. Now, I believe our max value, did I put 4.8 up there or something like that? I'm having trouble going back and forth. So what I'm going to do is just write the max. I think I had a 3.2 maybe and a 4.8 and a 4. Something like that. So let's just pretend that this is what the means were, just so we have data to go by. But we notice out of the 3 means or averages, the highest one is 4.8, which means that we kind of round up to 5. We need to go up to at least 5. And so if our max value is 5, we see that 20 divided by 5 equals 4. That means 4 lines equals 1 second. Okay? That means that each line then is 0.25 because 1 second divided by the 4 lines is 0.25 seconds. So I'm going to go ahead and set this up. 1, 2, 3, 4. There's 1. 1, 2, 3, 4. 1, 2, 3, 4. Now you don't have to always label all of them. There's not that many here, so I'm going to label all the seconds. 1, 2, 3, 4. And 1, 2, 3, 4. There we go. Now I'm using the entire y-axis. The next thing we do is we go down to our x-axis. Now, if we were using quantitative data and making a line graph or a scatter plot, we would do the same technique. Count the number of lines, divide by the max value of our data for our independent variable. However, we are not dealing with quantitative values. We're dealing with ground colors, the average speed per ground color. Okay, it is a qualitative data, and that's often signifies that we're going to be dealing with a bar graph or a histogram. The difference is a bar graph is discrete data, whereas a histogram is continuous data that has like this whole spectrum, like height. Okay, we're not just 5'5" or 6 foot. Like usually there is a spectrum of it, and you can kind of follow along the range. We'll talk more about that. The other difference is when you draw a bar graph, they do not touch. So with a bar graph, a couple of notes here about a bar graph. You want to make sure that your bars are the same width and that there is space between them and you keep it consistent. So I'm going to skip 2, just so it's not right there on the end, and I'm going to try making mine 4. 1, 2, 3, 4. And so I'm just drawing a line down here as the base of my bars. Skip 2, 1, 2, 3, 4. Skip 2, 1, 2. Yep, it will work. Always use a pencil just in case. I mean, I guess, gosh darn it, on the FRQ you will have to do a use a pen. So just be careful. Okay, so those are my bases. Okay, and we know, I think what was it? Was it black, white, tan? I don't remember, something like that, right? or brown. I'm not sure what it's set up above. Okay, so now I have them set up. The last thing I need to do is my title. So my title here, titles always have your both variables, your dependent variable compared to your independent variable. And so in this case, I just have to copy from the labels. That's what's nice if you do the labels. So in this case, average mouse survival time for different ground colors. So usually it's like whatever your IV or DV variable is, dependent variable, compared to, is in relationship to. For, you usually have some kind of like connecting word, transition word right there. And then you list your other label. Oopsie, colors, okay? And so that would be a label. Okay, now you're ready to graph. Now, going back up here, I said the first one here was gonna be, for our sample data, was going to be 3.2. So I go up to 3, and remember I said it's 4 lines between them, so that means 1 divided by 4. Each one is 0.25, and I'm going up to 3.2, so almost to that top line. 1, 2, 3, 4, and then I just color it in. Simple bar graphs, okay? And so you can go ahead and color those in. Y 4.8, so 5, not 7.5, it's gonna be above 7.5. Okay, so I'm just kind of making quick sketches here. And tan, I said is 4 even. That was a nice one, huh? I should have stuck like that. Nice whole numbers are nice to do. 1, 2, 3. I feel like I'm missing. Okay, I feel like, yep, I totally did. I went over too far on this guy. Okay, I'll try to make that bar a little bit clearer. And keep that bar a little bit clearer. Okay. And there you go. Now we've got the bar graph. The only thing we're missing though is the standard error. So if I just eyeball this, I say, hey, white has much higher survivorship, okay, than black, just with the sample data. Okay, that's what I want to say just based on the size of the bar. However, I need to find out if that's really true or if any of this change, the reason it's so high is just due to chance. So I'm going to plot in my error bars. Remember, 2 SEMs, 2 standard error of the mean, equals 95% of our data. That means in this classroom, 95% of you would have gotten either the mean plus or minus 2 SEM. So I go over here, and that 2 SEM was 0.22. Now I saw that 3.2, if I add 3.2, I come up with, and 0.22, it's 3.42. Okay, so all I'm doing is 3.2 plus 0.22, and then I'm going to do 3.2 minus 0.22. So 3.42, I'll go up here, 3.42 will be right like this. And I just draw a line there, and then I go down. 3.2 minus 0.22 is 2.98, I think. So right below this, and I go down, and I just draw little like lines, little hash marks. Then I connect them because this shows the range that 95% of our data is actually in. And that's how you plot it. And then I go through and I do the same for the other ones. And I'm just gonna draw some in, just to make it different. And then I'm done with the graph. I can tell if we can use this data or not to support whether or not mice have different survival times on different ground colors. So now when we go to answer our question down here, make a claim about whether or not camouflage would increase the fitness of a prey, we can say based on our data, yes, it does, or no, it doesn't, or only in some cases, these being the cases. So remember, if they overlap, okay, that data, we can't use it to support our claim because it might just be due to chance that the means look different, okay? The only way that we can use the data to support our claim is if they do not overlap. They do not overlap. Okay? So, hopefully this helps you guys with graphing it. If you have questions, please come to Impact. I will help you with the calculations, with the graphing, with answering the claim, evidence, and reasoning as well. Okay? Take care, guys.